All right, let's talk about another application of exponential decay. This is called a half-life question. So strontium-90 is a waste product from nuclear reactors. As a consequence of fallout from the atmospheric nuclear test, we have a measurable amount of strontium-90 in our bones. The half-life of strontium-90 is 28 years, meaning that after 28 years, the given substance has decayed about half of its original amount. Find the exponential decay model for strontium-90. So this one we're going to do, remember this model? We had this model earlier. Okay. Now, first off, here's how you do a half-life. Okay, let's say we have the original is here and the new amount's here. So if I were to divide by A naught, I would have A divided by A naught equals E to the KT. Okay. Now, if for a half-life, that means this is the original, this is the current amount, this ratio would have to be 1/2. So to find the half-life, the first thing I could do is I can basically just set this ratio, just set this expression here equal to 1/2. Now, K I'm not going to know. That's what I'm going to solve for. But T is the amount of time it takes that half-life. So T is 28. And now I can do the ln of both sides. ln of 1/2 equals, and then 28k ln E, that cancels, and then divide by 28. So ln of 1/2 divided by 28. These can get kind of small. So k is going to equal, and it's negative because it's decaying, so it's losing. So that's why I'm going to go 4 spots here. Because these can you kind of want to be as accurate as possible here. So now I'm going to plug this back into the original model. Now, I don't know what A naught is. I don't have an initial amount. So I'm going to have to put A equals A naught E to the negative. I don't really have much to give you right now, but this is going to be very helpful as I go to the next one, okay? So this is all I can do for right now because I don't have an initial amount, and the time is, is supposed to be a variable you're going to use in the model, but we're going to use this here. Suppose a nuclear accident occurs and releases 60 grams of strontium-90 into the atmosphere. How long will it take for strontium-90 to decay to a level of 10 grams? So it releases 60 grams, so 60 is equal to A naught. That's the initial amount. Okay. Decay to level of 10. So 10 will be basically your current amount. So 10 will be A. So now I can use this equation here. I have 3 variables, but I know the answer to 2 of them. So then I could solve for that last one. So 10 equals 60 e to the negative 0.0248 times t. Divide by 60, that'd be 1/6 equals e to the negative 0.0248 t. Then I could take the ln of both sides, 0.0248 t, ln of e, and I can divide both sides by negative 0.0248. These are not always the easiest problems to do. So ln of 1/6 divided by negative 0.0248 be 72.7248. So around 72 years for this to decay from 60 grams to 10 grams.